can observe from alternator R, it is connected to common terminal of ammeter, MI ammeter, and 5 amps range is connected to M as shown here. MC should be shorted, please this red wire you can observe, and L is connected to the synchronizing panel incoming machine side terminal L1. Please observe closely L1. So this is L1. Okay. Now you just observe from Y, you just observe from the diagram the Y. From Y, V of wattmeter W1 and V of wattmeter W2, it is connected. Please just observe. V of wattmeter, that is 600 volts, and another terminal V of another wattmeter. Both are connected, and from here you observe it is connected to the Y of, that is the second line of alternator. From here it is connected to again the synchronizing panel left side panel, that is machine side terminals in between, that is yellow terminal. And from B, that is third phase of alternator, it is connected to M. MC is shorted, and L is connected to the third terminal of the machine side connection, you can observe. So this finishes the alternator side connections, and of course the three phase supply, the bus supply is given to synchronizing panel second side. You can observe the bus, that is the third line. So this is connected to the C phase, so where you can see here A, B, C, and please ensure that all the three switches should be in off position. Pause it. Students, please be sure that in the synchronizing panel all the three switches initially before starting should be in off position. Otherwise will be in danger position. Is it clear? So now let us see the operation of first. We are going to run the DC motor, that is the prime mover initially as a motor, and then you can see here I am closing the DPS switch as shown here. See, the field restart of the motor is in minimum position. So if you rotate like this, the resistance will be increasing, and if you put like this, the field restart will be 0. So slowly, with the help of 4-point starter, I am going to start. So DC motor is operated at it should be operated at its rated speed. You can observe, initially the speed is 1375 RPM. You can observe, the speed is 1369 RPM. You need to vary and run it until 1500 RPM speed is observed. So you see here, the speed is okay. You can observe the machine is run at 1500 RPM. Clear? Now give the excitation, this excitation, and also give 3-phase supply to the alternator. Once if we turn on these two, we have to ensure the switches, machine switch and bus switch should be turned on. Please observe, after giving excitation and 3-phase supply, turn on the machine side switch and bus bar side switch. Closely observe, all the lamps are in bright position, and we have to see please observe. Now we have to synchronize the machine, that is incoming machine, with that of the bus. For this we need to satisfy 3 conditions. What are they? Phase sequence, then voltage across the terminal of both the machines, and frequency of both the machines should be same. When all these 3 parameters are matched, then only we can synchronize the switch. So otherwise synchronization cannot be done easily. For that, first we are going to check whether all the terminals are in phase sequence or not. Now we have turned on the machine side switch and supply side switch, first side switch. You can observe when the lamps are in on position, that is in right position, it does mean that there is a difference in the voltage between the machine and the bus. That means between the alternator, that is incoming machine, and the bus, there is a difference in voltage, and because of that you observe lamps are in turned on position. Now please observe, when I am wearing the field excitation circuit, you just observe whether lamps are glowing all at a time and getting turned on all at a time or not. First we will see. Just observe, all the lamps are brightening and getting darkened at the same time. So this indicates that both the machines, that is DC machine, that is the alternator, incoming machine, and bus phase sequence, both are matched. If they are not matched, we'll see how the lamps will be in glowing. I'll show you how the lamps will be operating. Students, please observe, I have interchanged two lines, machine side, and you just observe, I am wearing the excitation, and closely observe, please closely observe that, closely observe that these lamps, you can observe, at one time these two lamps are getting darkened, and again another two lamps getting darkened, like that. Alternately you are going to observe the lamps brightening and then getting darkened. This indicates that machine side phase sequence and bus side phase sequence are not matched. They are not in phase. That means the two machines are not in phase. So if you want to see that these two machines are to be in phase, then from machine side, please don't touch bus side. Machine side, you need to change the terminals. I will suggest you go for changing the yellow terminal and blue terminal only. No need to go for RP. So again, I am putting this to this minimum, and I am going to interchange the phase terminal. So now you can observe again, have to interchange the two terminals from machine side, and you can observe all the lamps are getting darkened and brightened at the same time. That means the phase sequence of both the machines is matched. You please observe even the synchronoscope also. Even in the synchronoscope, you observe the pointer and the LED bulb. So you can observe pointer is moving in the fast direction. That means one of the machine, it indicates that one of the machine is not having the same speed. So that I will tell you later on. First we are going to check the phase sequence here. So now we have to, so phase sequence is matched, and now we are going to match the magnitude of both the machines. Please closely observe. Left side of the lamp meter is alternator side voltmeter, and right side of the lamp voltmeter is related to bus side incoming phase, that is the supply side. You can observe the top meter. You can check whether it is there or not. Since the voltmeter to the left of lamp is not in proper condition, hence we have connected another voltmeter outside. 400 volts, we need to check it.
సరిపోయింది దాటింది తగ్గించండి
both sides should be the same.
సరిపోయింది
Yeah, students, observe, though phase sequence is matched and also voltage, we are going to check it. Magnitude of voltage is same, that is matched for both the incoming machine and the bus. Still we observe that the lamps are in alternating. That means lamps are brightening and getting darkened alternately. It does mean that still there is a difference in the frequency. Nothing but difference in the speeds of the two machines. It's because of the difference in frequency, we observe that a little voltage is appeared across the lamps. So we have to match even that frequency also. Therefore, we can observe the frequency of incoming machine side is closely shown. That the other one is the frequency of bus side, frequency meter. We can observe those two frequencies are not same. Those two frequencies are not same. Therefore, how to say that the two machines frequency should be the same? Here, we are going to vary this one. Please observe the synchronoscope is showing fast direction, sometimes reverse direction. So, now we have to vary the DC motor prime mover speed until you get same frequency there. Now I am going to increase, and you just observe I am increasing the speed, and you just observe incoming machine speed, that is alternator speed is very high. Hence the flickering of the lamp is also very high. Now I have to vary the speed in the reverse direction. You can also observe in the synchronoscope, please, the pointer is moving in the reverse direction. So you have to even reduce the speed, that is the field rheostat in the same direction, the reverse. Slowly I am observing, I am going to change. Just observe. So it here also. So the field rheostat is to be varied until you get all the lamps completely in dark position. So again, it's not happening. You have to vary the speed in such a way that both the frequencies should be matched, and then only all the lamps should be in dark position. I am just closing the synchronization switch when all the lamps are in dark position. So all the lamps are darkened and close the switch. You can observe the synchronizing switch is in on position. And you also observe the synchronoscope pointer is also aligning in the direction of LED. So this shows that even synchronoscope, from the synchronoscope method also, you can say that when this pointer is aligning towards the indicator lamp, always constant, then the matching, that is phase sequence, voltage and frequency are all matched. Then we have to close the synchronized switch. This switch is turned on. Now we can see that the incoming machine is synchronized with that of the bus. Clear? Immediately we have to turn off the DC motor supply. You just observe, I am turning off the DC motor supply means initially we have run that DC machine as a motor, and now I have removed the DC supply here, and even pointer is also, the 4-point starter is also in no position. Still you observe that machine is running condition. That means what? Alternator which we have synchronized with that of bus bar is now converted as a motor. It is acting as a motor now, and DC motor which initially we have operated as a motor is now operated as a generator. So DC motor generates power, and synchronous motor is acting as an input to the DC motor. So synchronous motor is taking power from the supply, and hence you are going to observe that alternator is still in running condition. Please do remember, for DC motor there is no supply, but how the machine, both the machines are running condition means alternator is now converted as a synchronous motor, which means that it is taking power from the supply. So now we have to take the readings. Synchronization part is done with the help of lambda and synchronous method. Now we are going to perform experiment on synchronous motor by varying field excitation of the alternator. Field excitation of synchronous motor. You just observe this one is to be brought back again. The field rheostat is to be brought back again initially. And see that it should be at its minimum, that is the current rating. Beyond that current rating, it should not be operated. Since the entire college is being run on that is alternator supply, not from DC bus bar, so we are going to get slight fluctuations here. So now you can see almost I can say 8.2 amperes.